Greetings to respected madams, sirs. My name is Pavan Sai from CSC AIML from the section C, and today my presentation topic is regarding iris flower clarification. And so this is my presentation's format. First, I'll be going through abstract and problem statements, introduction, requirements, prerequisites, technologies used, literature, survey, methodology, and the conclusion. First, I'll be starting with the abstract. So this project focuses on building an intelligence classification model to identify iris flower species based on numerical features such as sepal length, sepal width, petal length, and petal width. The iris dataset is widely used in AI and servers as an excellent introduction to supervised learning. The purpose of the work is to understand how logical programming, data analysis, and classification algorithms can be combined to design highly accurate predictive models. The iris flower classification project is one of the foundational problem in machine learning. It uses measurements of different flower parts such as sepal length, sepal width, petal length, and petal width to predict the species. The database contains three species: Iris setosa, Iris versicolor, Iris virgica. Using specification algorithm like logistic regression, decision trees, or k nearest neighbor, the model learning pattern and identifies the flower species with high accuracy. The project demonstrates how supervised learning works on structured data and server as starting point for AI and ML applications. So the problem statement mainly identifies plant species which can be time consuming and prone to error, especially when the species look similar. The goal of the project is to build a machine learning model that can automatically classify flowers into their correct species based on the four numerical input features. The problem requires clear data set, accurate prediction, a model that generalize well to unknown samples, easy interpretability. The main problem addresses in the project is automated identification of flower species using machine learning, manually classifying flower based on measurements can be time consuming and error prone. The challenge is to create an artificial intelligence model that can study numeric patterns and accurately determine whether a sample belongs to Setosa, Varisocolor, or Vertical. The model must be handling overlapping features, values, and produce reliable predictions for new unseen data. And introduction: the IRIS database was introduced by Ronald Fisher in the year of 1936 and is still used today because it is simple, small, and effective for classification. The datasheet contained 150 samples and 50 samples of each of three species, four independent features, one target variable. The objective is to train a model that maps input measurements to its correct species label. The project helps students understand data uh, pre-processing and model training, feature training, feature analysis, classification accuracy, logic based reasoning in AI models. S- Artificial intelligence enable computer to learn from data and makes intelligent decisions. The Irish dataset is a foundation data set consisting 150 samples of flowers categorized into three species. Each sample contains four attributes, and that helps distinguish among the species. The project used logical programming and machine learning techniques to classify the flowers. The work provided as a practical understanding of how AI models are trained, uh, tested, and evaluated in real world classification tasks. And the requirement for this project, the following requirements are hardware requirements, where a computer with minimum of 4 GB RAM, Python environment installed, software required are Python, Jupyter Notebook, or Google Colab. Libraries like NumPy, Pandas, Matplotlib, Seaborn, and Scikit-learn. These tools are help load data, performing analysis, build models, and visual results. The project requires a basic understanding of Python programming, knowledge of AI and machine learning concepts, and familiarity with numerical data handling requirements. Also includes the Iris datasheet, machine learning libraries, and such as NumPy, Pandas, Matplotlib, and scikit-learning, and tools for visualization data pattern, understanding supervised learning and classification principle in essential for successful complete the project. The prerequisites before the work on the project on one should know basic mathematical concepts such as mean variance and visualization skills, familiar with programming logic, darkset manipulation, and the concept like training and testing models is necessary. Knowledge of common machine learning algorithms like decision trees, logistic regression, or KNN helps in understanding how classification decisions are made. To understand the project on basic knowledge of the following concepts is required: Python programming, data structures and data types, basic statistics, supervised learning concepts, classification algorithms, evaluation metrics. The fundamentals helps in understanding why the model behave the way it does. The technologies used. The project used multiple technologies and libraries. Programming language Python, data handling pandas for loading and preparation data, visualization metabolic, and Seaborn for graph histograms, pair plots. Machine learning stick lean algorithms like k-near neighbor, decision tree, logical regression, support vector machine. These tools together create the full classification pipeline. The project used Python as the primary programming language because of its simplistic and extensive support for artificial intelligence. Libraries such as NumPy, Pandas were used for handling numerical data and pre-processing. The Iris datasheet, metabolic and C bonds helps in visualization the relationship between flower measurements. The sticky learns library played the most important roles of providing building in classification algorithms, data sheet splitting, tools and evaluation metric. Together these technologies enable smooth dataset analysis. Model training, testing and performing an evaluation makes the classification process effective and relatable. Literature review. Uh, Many researchers use the Irish datasheet as a benchmark for testing the new algorithms. Study shows logical regressions give good baselines accuracy. SVM and decision tree often achieves about 95% accuracy. KNN performs extremely well with optimal k value. uh, and assemble methods like random forest gives the best results. The data set is also widely used in educational AI courses because it is clearly demonstrates the separability between species, especially Iris cetonas. And the methodologies, the project began by loading the Iris datasheet and performing initial examination of its features and the structure. The next step uh, involves cleanliness, the data checking for missing values and ensuring the dataset is ready for analysis. Exploitation data analysis is performed to understand the patterns between features using scatter plotting, pair plots, and statistical summaries. The dataset is divided into training and testing sets to ensure fair model evaluation. A suitable classification model is selected and trained on the data which is training, after which predictions are generated for the dataset, test data. Finally, modeling accuracy, confessions, matrices, and classification reports are analyzed to determine the effectiveness of the models. The results in the discussion, the classification models produced highly accurate predictions showing strong performance across all three iris species. The model identifies Iris setonas perfectly because of its clear separated features values. Some challenges arose in different irises, Verosicolor from Verosica due to overlapping measurements, but the model maintained excellent accuracy overall. Visualization confirmed the petal length and petal width were the most powerful features and distinguished between species. The confusion matrix revealed very few misclassifications, proving the selected algorithm successfully learned the underlying patterns. The result demonstrates the even simple machine learning models can be achieved exceptional performance where when applied to clear and well structured dataset. The conclusion, the iris flower classification project successfully demonstrated the power of artificial intelligence and logical programming in solving real world classification problems. By analyzing numerical measurements and applying supervised learning techniques, the model was able to accurately predict the species of the iris flowers. The project strengthened understanding of data pre-processing, features exploration, model training, and evaluation. The result highly highlights the effectiveness of machine learning in biological identification tasks and showing how AI can support scientific researchers, agriculture, automation, and decision making. System overall, the project achieves its objectives and provides valuable insignities into practical applications of artificial classification problems. And thank you. I want to conclude my presentation with all this. Thank you.